Thank you. Our next speaker is Anjun Kanazawa. Anjun is a assistant professor in the Department of ECS at the University of California, Berkeley. She leads the lab called Kanazawa AI Research Lab CARE, which is very exciting. And then she will be talking to us about computer vision, computer graphics. Welcome, Anjun.
Thank you so much for the introduction. OK, all right. So that was music. That was a great talk. And then next, we can move on to a visual domain. OK, so I want to talk about this new creative horizons that are enabled with 3D capture, also 4D capture. And to begin with, I want to revisit this idea of going back to memories or experiences that we've experienced in the world and telling new stories with it. And this is actually an idea or a collective obsession, I would say, that we've had many times. Can someone recognize what this picture is from? It's very familiar one. And if you read the book, there's actually really interesting concepts about how the authors can actually visit their childhood bedroom and also new experiences. And this ability to want to enter this new virtual experience, old and new, is a recurrent theme in pop culture. So for an older generation, it would be holodeck. For a newer generation, it would be Harry Potter, where you can actually go into your memory and fly through them. And so today I want to talk about how far are we to this situation, and what are the kind of new creative tools that we can develop in this aspect. And I want to emphasize that this ability to capture reality is a very fundamental aspect of storytelling that we've been doing many times. And so here is one of the earliest cave paintings where we're telling stories about how we're hunting these pigs. Over 45,000 years, we got much better at drawing. And now we know how to render different types of lighting, which gives different impressions about the scene. And of course, we developed photographs and movies. OK, and these are the existing mediums in which we share our visual experiences. And they're great, but there's one thing that is missing from these mediums, which is that the world is three-dimensional. And these are only a two-dimensional capture aspect of that world. And so for this, computer vision community and the graphics community has been working on reconstruction. This is a super cool results from 2009, where we could take tourist photos in Rome and then get these reconstructions of the city. And this is the underlying technique under your everyday devices, like your Google Maps or Google Earth. And in this domain of 3D, capturing reality in 3D, I want to talk about this new frontier called neuroradiance fields that came out in 2020. And I know this is a broad audience, so maybe you haven't heard of this whole situation. And so let me just make clear what is the input and what is the output. OK, so there's a new 3D capture, requires lots of images. And that images, which is calibrated or known camera poses, which is illustrated as these frustums in each of these pictures. So each of these little rectangles are an image, OK? And their location and orientation signifies which direction did you capture the picture from. OK, this is a lot of information you need to know, that you need to do lots of processing. But that's the input. And given this input, the algorithm goes as follows, which is to take out every single image and then reconstruct every single pixel. That pixel is reconstructed using volumetric rendering. In this case, it is neural network. But you can currently just treat this as black box volumetric quote-unquote neural, because sometimes it's not even neural representations. But the point is that they will output for every single point in the world a color and a density. It's like a fog, colorful fog, OK? Colorful particles. Then once you can actually query these colors and particles of the fog, you can actually integrate this along the array and then recreate the pixel. And the objective is to reconstruct all the images that you have seen. And there's an underlying 3D representation that if you can explain and reconstruct all the images, eventually that will give you a nice 3D reconstruction that allows you to fly through. And so from now on, I'm going to use NeRF as a loosely, this type of approach that optimizes via analysis by synthesis is how we call it, this type of optimization with a volumetric 3D representation or approximation of this. And so, since it came out in 2020, there's really been an explosion of this field. And I really think, there's a lot of progress that was in the field before 2020, but this NeRF was really easy to optimize and enabled a lot of things. And so I thought that you might actually find this timeline interesting. It's very interesting for me. So this is since when NeRF came out. It's kind of interesting. NeRF, it's already been almost 4 years since it came out. And so in March 2020 was the first time NeRF paper was released on the internet. And this had really remarkable results. It had these shiny things. It was very difficult to capture. And everyone was excited about it, but the initial instrumentation of it was very impractical. To render an image, it was like 30 seconds. You could never use this in a real system. Just a year later, my lab and other labs made it enabled to do real-time rendering, as you can see in these demos, where you can actually interact with the scene. And these types of efforts got us to think about novel or like architectures in which you can actually train this really quickly too. So here is the visuals where the thing on the left actually got rid of neural networks, and it actually trains really fast. So it got much faster to train in a real-time feeling. Of course, around this time, a student, Matt Tansik, who went to Waymo for an internship and then used all of the footage from Waymo to reconstruct the city of San Francisco. And then in September 2022, Dream Fusion kind of distilled these 2D generative models to create new 3D objects. And of course, this summer, there was Gaussian splatting, which is like the latest version that is like nice quality and speed. And so lots and lots of things are happening in this area, and then we're still not until March 2024. In this landscape, I want to talk about one project that my group has been doing, which we really started thinking about this in March 2022. There's so many nice papers. Like at this point, there's like 2,000 papers on NeRF. And then, there are lots of complementary ideas that could be put together. But everybody had their own repository, and it wasn't really easy to put together. More than anything, it was not easy for me to actually go and capture NeRFs. And so we actually put our head down for almost a year. We did this in-test software engineering project and created this thing called NeRF Studio. NeRF Studio is also a paper that we just presented at SIGGRAPH. But it's also a big, big open source project by this point. And our design goals were to make it easy to use, develop, and understand what all of these techniques are. At the end of it, it's an end-to-end framework that you can actually take your everyday devices. Like your parents can take a video of your bedroom or something. And then we implemented all of these technical ideas in a very modular way. And we also have this web viewer, which I will discuss more, where you can actually fly through the scene yourself in an interactive way and export it in many different ways. And so it's very important that actually, whenever you look at these cool results in 3D, to go and actually fly through the scene and actually look at it yourself. Because, like I said, these are the actual captured videos. NeRF only reconstructs what you see so far, okay? And so if you've never captured it, it would just not know what to put there. And so it's really important for you to actually go around the room. And then here is, for example, a render that comes out of our system. Of course, like I said, it requires you to solve structure for motion. I'm happy to talk about what's the difference between photogrammetry and NeRF offline. But these are very common softwares that people use to compute cameras, and we are really easily integrated with this. I'm not going to bore you with the details of the modularity of the method, but I would like to tell you this picture, which is kind of our default model. And it combines the colors in each of the text reflects which paper it comes from. And so the point is to show that it's very easy to plug and play different ideas to actually achieve the best balance between performance and easy development. All of this is like Python and easy to develop. We also have super active Discord community, and we're continually developing this. So the first version of NeRF Studio, NeRFacto, kind of look like this. It's pretty, it's okay, but but then we realized that you can just actually make it much bigger. We've been continuing to develop on this, and this is one of the recent results that we can actually take from a hike. And these kind of results are quite challenging scene to capture with the traditional photogrammetry because there's a lot of amorphous structures, thin structures. And you can fly through, and it's like super cool. And if you're into this area, we're also having an implementation for Gaussian splatting, which is going to come. And then we're continuing to work on the viewer situation. It's really important for you to be able to actually play around with your models in an easy way to get different visualizations. If you're a researcher, you're trying to develop a new model, maybe you have like a custom input that you want. That's really easy to integrate in this. So it's more of like a research aspect. But I'm super excited because my students are also developing these, we're doing a revamped version of a viewer, which enables mobile. And you can actually, here's us actually using the mobile viewer, and it's in a shareable links. And I think these are super exciting things that we've built. Anyway, here's one of my students who's trying it out in the airplane, and he's excited about it. Okay, all right. Okay, and then given all of these tools, you can export it in as a video point cloudner for mesh, create these cool camera effects like dolly zoom. The super nice thing about being an open source is that people just come and implement cool things. So there's this undergrad who just came and then integrated with the Blender to do these cool VFX effects so that we can actually have these, this is my office actually, in front of my office, and we can create all of these cool tools or visuals that combines traditional 3D artist tools with these new captures to create new content. People have also composed, put objects into it, like an AR situation, or capture this super cool night scene, which is also hard to begin with, and then apply this type of point cloud renders to create these super creative, cool scenes. Here's another one of these variations, and this is Berkeley Rose Garden. If you're ever in the Berkeley area. Now I am running out of time, so let me skip on these unfortunately beautiful videos. Okay, let's see if I can. Oh, well, it wants to play itself. Okay, and that's the university. All right, so this is the tool that we've made, but I would like to talk about the research that is being done on top of it to kind of give you this insight into more horizons into what you could do. These videos really like to play itself. Okay, all right, so not just our group, but many people are actually implementing their papers in their studio. And so one thing we can do is now we can actually capture our friend Frederick in my lab really easily, okay? And then maybe actually what you want to do is not just 3D capture him, but maybe edit him, maybe give him a mustache. Or, maybe change it all together, like maybe make him into a bronze statue. And so I'm actually kind of hoping that this is the kind of edit that I think managers at the 3D companies would be like, oh, okay, I get it why you want to try to do this in this new representation. Because there's often the question of like, why don't you want to do this in a mesh? And the thing is that to make any of these edits, it's very hard to do it in a traditional way, or regionally it's easy. But this is like a very holistic contextual edit. You could even actually make him into a painting, and it will actually change the whole entire scene, right? And so that's kind of what we're going for, which is a contextual edits. Instead of just editing a single parts of the scene, you could actually say, make it just look like just its node. And I think a hybrid approach is definitely necessary, where an artist can go in and have the freedom to change a specific thing that they would like to have, but employ these generative approaches to do these contextual edits. And of course, we're building on instruct Pix-to-Pix or these stable diffusion-like approaches. The nice thing about the model that we choose that it's an instruction. It's nice not to have to explain the whole scene in language. I think pixel is worth 1,000 words. Without getting too much into the detail, I want to talk about this, which highlights the challenge of what we're trying to do. So take all of these images that we've used to capture this scene. You could actually take every single frame and then run it through instruct Pix-to-Pix and then get an edit with the exact same instruction to make it into a grizzly bear. But then if you do this, the 2D generative models are not going to give you 3D consistent edits. And this is why you actually see all of these floaters. The floaters are the stuff that cannot be explained in a single scene. And this is why they'd like to put it right in front of the camera, so that for every single camera, that is satisfied, but not globally. And so there is a real need to develop new algorithms that enable consolidation of these edits, or tying these 2D generative models, which are restricted to 2D, with the 3D domain, without actually having to have this 3D data. And that's the kind of algorithm that we develop. And in this case, I don't want to get into the details, but basically we're kind of using the 3D global structure as a glue to kind of make everything consistent in a slow kind of like maturing way. Okay, so that like slowly you're going to achieve the kind of edits that you would like. And this enables us to make a really cool scene. This is a scene that Matt captured in Hawaii. We can make it sunset. And I really like the sunset because this like changes the whole global lighting, as well as this backdrop, which would be hard to do. And we can actually make all of these different kind of edits. But unfortunately, I have so many more slides. So we can also do this on humans. All of our code is open source. And here are some cool edits that people have made on their own data. The other aspect that I would like to talk about is that so far, 3D is nothing but a particle of colorful particles. It's just like pixels, right? There's no meaning to it. But you can actually optimize clip representations in these 3D representations so you can actually search them. And so here are the two main authors of this paper. They went to Paris for this conference. It's very easy to capture these scenes right now with Nerf Studio. And then you can actually do these super long tail queries about like what's in the scene. And I'd like to emphasize that this is much better to do this in 3D than in 2D. Here's a direct comparison with a 2D clip, which will kind of localize the object. But once you have 3D and lots of different views, it allows you to really refine the activation to a specific region. And so you can get really high quality relevancy map. And then you can also do automatic crops according to this, like give me a bouquet, and it'll just crop you a bouquet. This would be a really cool way to generate assets from the scans that you can have on your desk. Another nice application of this is that, if you actually want robots to have common sense when they actually manipulate with it, these are very good ways because robots exist in a three-dimensional world, and to have semantics enable them to interact in a way that is, we can specify how to interact with the world. Other aspects of the research is like, everybody shows you pretty pictures on Nerf, but if you don't do the right capture or the capture is casual, you're going to get a lot of these floaters. And these floaters are parts that you've never seen. And so we're actually incorporating some kind of uncertainty metric so that we can actually get rid of parts that aren't really certain. And the nice thing about this direction is that once we've removed these things, then it gives us an opportunity to fill it in with new content that are plausible or specified by people. So that's like a new direction that we're excited about, or we've been working on this for a while. It's a hard problem. With that, I would like to drop a little bit of pictures of the impact of this in industry. For full disclosure, I am an advisor at Luma, which is a company that started my students, and also Matt joined recently. And that is making these capture available through your app, making it really easy. And I really love this footage from Corridor Crew. This is really related to creativity, different ways of shooting. So, shooting film requires skill. Like, you got to be able to do that kind of camera motion. But now, with Nerf, you can actually shoot your scene like that. And then you can still result in these kind of nice, smooth scenes because you can render a new path. Okay, and so Luma also has these cool visualizations of the viewers to generate your own video. But admittedly, applying these cameras, at every single point and placing a key point and moving it around is not that intuitive, and it's not that nice. And so this is a super cool demo from Karen Chang, where instead you can actually, using the app, pretend that you're the camera and actually reshoot the scene. Make the scene smaller so that you can actually fly like a drone in the scene, and then record this camera motion, and then re-render the scene with it. And that will give you this super cool video that is really also intuitive to generate. This is also integrated into Unreal Engine so that you can actually use it with a traditional pipeline. People are starting to use this for music videos, game assets. And I have this 1-minute video that I would really like to play, and I would have scripted if I had a control of the computer. Anyway, you can go into your room, capture a scene with these cereal boxes, okay? This is still quite manual, and a lot of it can be accelerated using the tools that we will develop soon. But once you capture all of these cereal boxes, you can actually move them around and kind of construct the basis of your virtual city, perhaps. And what you can do is after you move all of these things around, you can actually add some lighting, and you can actually render this from novel views. And not only this, because I'm like, what do I want a city full of Cheerios? You can actually go and then apply these generative AI filters and actually create these super fantastic sceneries from your everyday devices on your desktop. So I think that's just super cool. And so that just kind of hints at the kind of things that are available that were only available to like huge, music, film productions, but now any creator can do. And before I end, I want to point out one thing that is missing from all of these conversations, or the stuff that I've shown. I mean, there's many things missing. There's no sound, for example, or multimodality. But one thing that's really missing is that the world is 3D and dynamic. There's all these people. Where are the characters in there to tell the stories? And this is actually my other line of work that I've been working on for a very long time, which is to extract these 4D reconstructions of people and other animals. And we're making really good strides for humans. We just released this new approach that is really robust and can actually recover these poses from very challenging videos in 3D, approaching markerless motion capture. And these are the kind of the technologies that are foundational in this. Doesn't play video? Can someone press the video? It's too bad. If this video played, this is a robot, but then the robot is a video, and it was inserted. I need to click on it, unfortunately, so sad. It's a video of a normal person, and then you can just drop a robot into it. And this is actually a startup that's also using these technologies to do it. And so that really enables you to insert characters and tell these different stories. Oh, there you go. It did play. OK, so this footage, which would be really challenging to make, but it actually can be captured from your own footage, and you can generate all of these things. And so this is actually available. It's no longer beta. You can actually go and try this out. OK, so concluding thoughts. I think it's super exciting stuff. There's still a lot more to be done. I think if you want to create new experiences or even revisit old ones, there's not going to be enough observations, so you have to fill it with your priors. There's a question about data. How are we going to get the 3D data? Because there aren't that many 3D data. Can we learn this from 2D? What are we going to do with moving stuff? How can we insert more other multimodal cues like language or sounds? And so those are really interesting stuff. So there's a lot more in this area. But I think it's very exciting. And lastly, I want to thank my team. Without this, it's not possible. So thank you.